What did you come up with? I really wish you were here, and then you could tell me. But, oh well. Okay, so write a function g whose graph is a reflection in the x-axis. So again, that's negative f of x. So I'm just going to do negative f of x, 3x plus 1. We are going to distribute that negative, so I have a negative 3x minus 1, and they want us to call it g. So that is my new equation. So this is what happens when I take 3x plus 1 and they say flip it over the x-axis, and then that's what you have. Okay, so reflection in the y-axis or over the y-axis. Again, we're going to go like this. Okay, this is the original, this is the reflection. Okay, and instead of the negative being out front here, it's only the x value that becomes negative. You may not see much of a difference, but there's actually a huge difference here. All right, so let's look at an example. Okay, same one we had before, and this one's kind of tricky. They're not going to be this bad. This one's a little funny, but so what we're going to do is we're going to do f of negative x. So this is when we put in negative x for x. That's it though. Okay, not everything else is going to be changed. It is only the x value. All right, and so because this is an absolute value, if you were to leave it like this on a test, it would be fine. But because it's an absolute value function, I kind of have to manipulate it just a little bit. And so what this becomes is negative 1 times x minus 3 plus 1. So I just factored a negative 1 out of these, and now I can chop these up. And the absolute value of a negative 1 is 1, so that kind of goes away, and I'm left with the absolute value of x minus 3 plus 1. So I started with this. They asked me to reflect it over the y-axis, and I end up with this function. Okay, I promise the example, or the one I want you to do, is easier. But here it is. Here's the original one. And this is what it looks like, when it is reflected over the y-axis. Okay, so here's one for you to try. So go ahead and pause right now. Did you pause? Because I feel really dumb standing here like this. Okay, I'm going to pretend like you did pause. All right. So f of x equals 3x plus 1, and this is a reflection in the y-axis, so I know that that's going to be f of negative x. So again, I'm just plugging a negative x into here, so I have 3 times negative x plus 1. This is going to give me negative 3x plus 1, and they want me to rename it g of x. And if you're really excited about this, you could put it into Desmos.com and graph both of them, and you'll see how it's flipped. It's kind of cool. I actually really like Desmos. Okay, so vertical stretches and shrinks. I actually don't really like this picture very much, but I don't know. These pictures haven't been that great. They're actually probably pretty confusing. But I did want to give you a visual of what it's doing. Okay, what we have is we have the number multiplied by the entire function. Okay? If a is bigger than 1, it's a stretch, right? Because if I multiply something by a number bigger than 1, it's just going to get bigger. If a is between 0 and 1, then it's a shrink. It's going to get smaller. So for this, we stretch like this, and we shrink down like this. So stretch, shrink, I you remember that, because I looked like a fool doing that. Okay. All right, so for example, here we've got this function. Write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So I remember that a vertical stretch is a times f of x. And my factor is 2, so a is 2. So I'm going to do 2 times f of x. And this is just 2 times the entire thing. X minus 3 minus 5. And I distribute the 2. So it's 2 times the absolute value of x minus 3 minus 10. Okay? And here is a picture of the graph for this. So here's the original. Here's the original. And I'm not sure why the vertex changes. I would have thought the vertex wouldn't have changed, but I don't know. But anyway, it gets bigger faster. You can see here's the original, and this one just goes whoop, and it goes up a lot faster, so it's stretching. All right. So I want you to try this one, and we'll get the answer to that one on the next video.